Hey guys, Mrs. O'Donnell here. Just making a quick video to talk about our intro to functions since I'm going to be out for working from home for a few days. Okay. We have a lot of goals this week, but really what you need to take away from our goal list is that we've got a lot of vocabulary. So it's really not anything mathematically new. It's just new vocabulary for things that you've already been doing. You've already been working with relations and functions for a very long time. We're just going to start talking about them in a different way. Domain and range, you've already been working with. Domain is typically the input, the x's. Range is that output of your function, your y's. You've already been working with that. We're just talking about it differently now. Independent and dependent variables, you've already been working with. We're just going to start identifying them more. And you've been doing that in your bio classes, I think, as well. It's the same idea. Linear functions, we're going to talk about those a little bit more. Discrete versus continuous and discontinuous graphs, we're going to talk about that. And function notation to evaluate and interpret functions and graphs. You've been doing all of these things. Okay, pay attention to today after I push out this video, I'm going to push out the self-reported grade survey, which you guys see right here in the agenda. Okay, complete that survey, be honest with your answers, and then at the end, you're giving yourself a grade. So remember, your score out of 10, think about it like a letter grade. If you give yourself a 9 or a 10 out of 10, you're giving yourself an A, saying you've really given your best effort this week. If you're giving yourself a 5 out of 10, you're really giving yourself an F, saying that you really didn't try much this week, all right? So really think, same thing, like a 6 would be a D, a 7 out of 10 would be a C, an 8 out of 10 would be a B. So really think about what grade you're giving yourself. All right. I'm going to kind of skip through some of this stuff to get to the meat of our lesson. Since it's a video, I have 15 minutes to get a lot of info to you. Okay, so what comes first? This is how we identify our independent and dependent quantities. Okay, when one quantity depends on another in a situation, it is said to be the dependent. And this is good for you to take down in your notes. The quantity it depends upon is called the independent quantity. Okay, consider the two quantities that are changing in the relationship below: the number of movie tickets purchased and the total cost. So a question that's really helpful for you to figure out what is the independent and what is the dependent would be asking yourself, what comes first? What is the thing that has to happen that needs to happen no matter what, right? So if you're going up to the counter to purchase your tickets, the first thing you have to do is tell the clerk how many tickets you want, right? So you need to know the number of movie tickets that's being purchased. That would be the independent. And then the total cost, that's what the clerk would tell you after you say, oh, I want to buy 4 tickets. Then they're like, okay, you owe me $50 or whatever the case may be, right? So that would be your dependent. Okay, cool. All right, here's some practice problems. You could go ahead and try these. If you have any questions on them, let me know. Now we're going to start talking about some key vocabulary and characteristics of graphs. So first of all, what you may notice in these graphs is these 4 graphs are all made up of dots. This is what we call discrete. They are also discontinuous. Okay, so discrete graphs are specifically made up of dots, and discontinuous graphs are graphs that they may not necessarily be made up of only dots, but they're graphs that when you're graphing them, you would have to pick your pencil up at some point, okay? They're discontinuous. Some other characteristics that these graphs have in common: they all go through more than one quadrant, and they all pass through the y-axis, okay? Here, what you'll see, these graphs are grouped together because they all have sort of symmetrical end behavior, right? If you check out sort of the directions at the end, I know this one is discrete, but if you think about if there were arrows, right? They've all got this sort of symmetrical end behavior, okay? And you see a couple of different kinds, right? This V shape, this is our absolute value graph. We'll start talking more about function families. This U shape is our quadratic function family, okay? All right. So Dylan grouped these graphs together incorrectly. He's saying that they all go through only 2 quadrants, but if you check it out here, okay, and this is something to really pay attention to. When you have these graphs with these arrows, it's saying that the pattern is continuing on, right? So just because that you might only be able to see a certain portion of the graph does not mean that the graph necessarily ends there. And this really is important to keep in mind when you're using like a graphing calculator or Desmos. You may have to change the window size to see the whole picture of the graph. And you may have to start thinking abstractly, well, I see it's continuing on, so I know that it's continuing on forever in that pattern. Excuse me. Okay, here we have some graphs, and these graphs are grouped together because they're all not functions, and we'll talk about that more in a minute. You may or may not remember from last year what's called the vertical line test. If you had Mr. Eckert, he called it the Mr. Eckert pencil test, where you take your pencil and you put it on top of the graph, right? And if your graph touches that pencil in more than one spot, it fails the vertical line test. So you see that these graphs all fail at some point, fail the vertical line test, right? This is a vertical line. It fails infinitely many times, right? It fails everywhere on the vertical line test, okay? So these are all not functions. So let's talk about what makes something a function and not a function. So a relation is the mapping between a set of input values called the domain and a set of output values called the range. Okay, and oftentimes we consider the domain the x's and the range the y's, but sometimes we use different variables, right? So it's not always the x and the y for domain and range, but oftentimes it is. All right, and then here's just some different examples of ways that we've already been looking at relations, right? We've used tables before. We've talked about ordered pairs. We've read verbal, scenarios. We've seen graphs, equations, and then this is called a mapping where you have your input mapping onto your output. All right, let's see here. Function is a relation that assigns to each element of the domain exactly one element of the range. Are these functional relationships? So if we're thinking about, taking a friend to a dance or, dating relationships, right? A functional relationship would be where each person on the input is only dating one person on the output. Each domain goes to only one range. Okay, so this would be an example of a function or functional relationships. Versus here we've got Michael, who is dating both Jenny and Riley. And that's a problem. Really, the fact that Michael is dating two, there's one input going to two different outputs. This would be an example that is not functional. Not a function, okay? You've got one input with two different outputs. Okay, so are these functional relationships? So again, here you've got John and Susan and John and Lisa. You've got one input to two different outputs, so it is not a function. Right? Same thing here. You've got Rico, who is going to both Sarah and Beyonce, right? Not functional. Okay? And if you look at what that looks like numerically, right? We've got repeating X values, okay? With different outputs, different ranges, Okay, so these would be not functional. And if you graphed those, they would fail that vertical line test. Same thing down here. 2 is going to both -3 and -11, not functional. Okay. All right. I think this is one of our last things, function notation. Function notation is taking our equations and it's just giving it a new name, right? So it gives us a little more information and allows us a higher rate of efficiency with our mathematics. We can write more mathematics in a shorter space on the page, which is really helpful when we get into that higher level mathematics. We need to be able to condense down what we're writing. Okay, so it's taking this output value, instead of writing it with a y, we're now naming it using this function notation, f of x. Okay, so f of x is one whole thing together. It's not just the name of the function f, but it's f of x. It tells you both your output and it tells you the variable that you're operating on inside your function. All right, your independent variable. So what is the independent variable in this shirt function, the c of s equals 8s plus 15? Well, the independent variable would be the s variable. And then what is the dependent variable, or that output? And this is what's tricky. Oftentimes I have students who tell me the output is c, but it's not. The output is this whole thing, c of s. Okay, even though it's 4 separate characters, it's one name. Right? Just like .com, how we have that .com button now because it's one thing. You wouldn't write DCO, right? Or .c, it's .com. It's C of S. It's one whole name. All right. All right, and the last thing I want to talk to you guys about today is the vertical line test. We already talked about it a little bit. Basically, if there's at any point you can draw a vertical line and it touches your graph more than once, then you know that your graph is not a function. So here we do have a function on the left and we do have a function on the right, but this middle one is not a function because it fails that vertical line test. That's your quick summary of functions. We'll get into domain and range a little bit more next week. We'll do some Desmos. Thanks, guys. If you have any questions, please email me. Bye.